Within the technology community and among closed analytical circles, there is growing discussion about the possibility that Elon Musk is preparing for one of the most high-profile announcements of recent years: a full-scale release of a new generation of Tesla Optimus humanoid robots. And this is no longer about prototypes or demonstration versions, but about a product that is nearly ready for large-scale deployment. According to several sources, including insiders from Silicon Valley and publications in authoritative outlets such as Bloomberg and The Information, Tesla has accelerated internal testing, sharply increased hiring of engineers specializing in biomechanics and neural network systems, and also begun procuring components that had never previously appeared in the company's supply chain. All of this points to one conclusion: this is not just an update, but a fundamentally new generation of robots that could redefine what a humanoid assistant is supposed to be. Particular attention is now focused on the design of future Tesla Optimus units, because according to people familiar with the project, it will change dramatically. While previous versions of the robot looked like typical engineering prototypes, functional but still far from a human appearance, the new generation, judging by leaks, will aim for maximum biomimicry. And this is where it becomes especially interesting. Several insiders claim that Tesla is testing a new type of synthetic skin, a material that not only imitates the appearance of human skin, but is also capable of responding to touch, pressure, and even temperature. This is not just a decorative layer, but a full-fledged sensory interface that turns the robot's body into a distributed perception system. If this information is confirmed, we are talking about a transition from a tool-like robot to a robot organism, albeit an artificial one. Such skin could contain thousands, or possibly millions, of microsensors distributed across its surface, allowing the robot to literally feel the surrounding world. This means Optimus could operate in far more complex environments, interact with humans more safely and precisely, and perform tasks that require fine motor skills and delicacy. For example, elderly care, medical assistance, handling fragile objects, or even roles in service industries where tactile interaction matters. But the skin is only one part of the revolution. The second key element is the hands. According to information that has appeared in several engineering blogs and is indirectly supported by statements from Tesla itself, the new generation of Optimus will feature manipulators with a number of degrees of freedom approaching that of the human hand. This means not just bending and extending fingers, but full articulation, including rotation, micro-adjustments of pressure, and even imitation of so-called muscle softness. In other words, the robot will not simply grasp an object, but will do so as carefully as a human, adjusting force in real time. Why is this so important? Because hands are the main limitation of most modern robots. A machine can be intelligent, capable of seeing and analyzing, but if it cannot interact with the physical world at a human level, its usefulness drops sharply. Tesla, it appears, is focusing precisely on overcoming this barrier. And if they succeed, we may get a universal task executor, from industrial applications to everyday use. Another notable point is the information suggesting that alongside the new generation of Optimus, several robot product lines may be introduced at once. This may sound like a bold assumption, but it has a logical foundation. Tesla has repeatedly demonstrated a strategy of product diversification within a single ecosystem. It is enough to recall its vehicle lineup, which includes both mass-market models and premium solutions. By analogy, it can be assumed that Tesla Optimus will be presented in several variants: a base version for home use, an industrial version for factories and logistics, and possibly specialized models for medicine, security, or even military applications. This raises the question of cost. How much could such a robot cost? According to estimates by Morgan Stanley analysts, the base version of Optimus in the long term could cost between $20,000 and $30,000, making it comparable to a mid-range car. However, at launch, the price will most likely be significantly higher, possibly in the range of $50,000 to $80,000, especially if we are talking about a version with advanced sensory skin and high-precision mechanics. Premium models designed for specialized tasks could exceed $100,000. But it is important to understand that price is not just a number, it reflects value. If a robot can replace one or even several employees, operate 24/7, require no vacations and perform tasks with high precision, its economic efficiency becomes obvious. This is why large corporations are already showing interest in such solutions despite the high cost. At the same time, the deployment of this technology inevitably raises risk-related questions. The first and most obvious is safety. If a robot gains skin and becomes more human-like, it also becomes closer to humans, increasing the potential consequences of errors. Even a minor malfunction in the control system could lead to injuries, especially in scenarios involving human interaction. Tesla will likely implement a multi-layered safety system, including force limitations, instant shutdown mechanisms in case of failure, and continuous system monitoring. The second risk is social. The mass adoption of humanoid robots could lead to significant changes in the labor market. Millions of jobs, especially in physical labor sectors, could be at risk. While this may create new opportunities in other fields, the transition period could be highly disruptive. Economists are already discussing the need for new social support models, including basic income, to mitigate the effects of automation. The third aspect is ethics. When a robot becomes visually and behaviorally similar to a human, the question arises of where the boundary lies between a machine and an artificial being. Should new norms of interaction be introduced? How can misuse be prevented? For example, the use of such robots for manipulation or illegal purposes. These questions remain unanswered, but it is clear they will become part of public debate in the coming years. Nevertheless, despite all the risks, the potential of the technology is enormous. Imagine a world where everyone has a personal assistant capable of handling household tasks, helping with work and caring for loved ones. A world where factories operate almost entirely autonomously and logistics becomes instant and efficient. A world where the boundary between digital and physical disappears, and artificial intelligence gains a body and becomes a full participant in reality. Elon Musk appears to envision exactly such a world, and if current leaks and indirect signals are to be believed, that world may be closer than it seems. The new generation of Optimus is not just another product, it is potentially a turning point after which technological progress could accelerate even further. And perhaps in the coming months, we will see the first real evidence that the future long discussed is finally beginning to become reality. It becomes clear that we are dealing not just with a robot, but with a new form of digital physical intelligence. This could ultimately become the factor that sets Tesla decisively apart from its competitors and transforms Optimus from simply a product into a platform upon which an entire future industry will be built.